It's a great day to be alive. We're going to be doing some parallel proofs. The same old proofs you've done. Statement, reason, given this, prove that. But we're going to be applying all the new things that we've been talking about with parallel lines and transversal. So basically, you've got your linear pairs, vertical angles, corresponding angles, alternate interior, alternate exterior, and your consecutive interior. If you could prove any of these relationships, for example, if you have alternate interior angles that are congruent, you've got parallel lines. If you've got corresponding angles that are congruent, you've got parallel lines. If you've got consecutive interior angles that are supplementary, you've got parallel lines. In addition to this new stuff, we're going to be using some of our old stuff. We've got substitution, your definition of this or that, symmetric property, transitive property, etc., etc. The same things we've done in the past. A couple new things that you're going to want to know is the symbols for parallel. If I had two lines, let's say two lines R and S. If I wanted to say that these lines were parallel, my symbol I would use is these two parallel lines. R is parallel to S. These two vertical lines mean parallel. Just as a refresher in case it comes up, remember these two perpendicular lines means perpendicular. So let's say R is perpendicular to T. That means we know there's a line here of T that forms a right angle. So keep in mind these two symbols. You've got your parallel symbol and your perpendicular symbol. You definitely want to keep in mind when doing parallel proofs is sometimes they have hidden parallel lines and transversals. For example, say we've got this shape right here and we've got a diagonal coming across, and we know that these two lines are parallel. Now, this doesn't particularly look like parallel lines in a transversal, but if we focus in on this right line here, and let's pretend that we just extend this line out like this, and this other parallel line here, and we extend this line out like this, if we extend this diagonal across, now we're starting to recognize that we do have parallel lines with a transversal, and I can tell here that we've got here and here alternate interior angles. So I could actually say that in this shape, this angle is congruent to this angle over here. Here we've got two triangles kind of connected at their points, and it doesn't look like we've got any parallel lines or transversals. But can you spot the hidden parallel lines? Well, let's say we extended this line out here. Let's extend these two lines here. Now we've got this angle and this angle that are congruent. Those are alternate interior angles. So if these alternate interior angles are congruent, then we know that these two lines have to be parallel, because parallel lines with the transversal always have alternate interior angles that are congruent. Okay, really quickly I'm going to walk you through an example proof, and then I'll let you get to it on your own. So here we are given triangle AD is isosceles, triangle ABC is isosceles, measure of angle A equals 60, and we want to prove that line DE is parallel to line BC. Now I'm not going to do a statement reason just to save you some time, but I'm going to talk you through the whole process and see if you can get the general idea of it. So first let's go ahead and label what we know. I know measure of angle A is 60, so I'm going to go ahead and put 60 in there. I know I've got isosceles triangles, so I know that D is going to be congruent to E. I know that B is going to be congruent to C. Again, because I've got ADE is isosceles and ABC is isosceles. Now, looking at this, I do notice that I've got triangles here, and I know a triangle, the interior angles add up to 180. Looking at this top triangle here, I know I've got 60 out of this 180, so I know that D and E have to add to 120. Well, since these are congruent, I know these have to be equal. That means that each of these are going to have to be 60 degrees. These are congruent, and all three add up to 180. Similarly, we've got this triangle ABC. Again, these all need to add up to 180. We're left with 120 left after you take out this 60 degree angle. So these are also going to have to be 60 degree angles down here. Okay, let's look at what our goal is now. We know line DE, or we want to prove that line DE is parallel to line BC. Well, we've got line DE here is parallel to line BC. This might be one of those situations where we have secret parallel lines and transversals. So let's go ahead and extend some of these lines out and see if we could picture anything. Let's extend this out here. Let's extend this out here. And then I'm just going to go ahead and pick one of these because we've got kind of similar situations. Let's pick this line here on the left, and I'm going to extend that out there. Okay, now looking at these, I've got two lines and a transversal. Notice here, these angles are corresponding based on our new picture, and they're both equal to 60 degrees. So, for my final statement and reason here, I can say that line DE is parallel to line BC, and my reason would be because these angles are congruent to one another, that would just be congruent, corresponding, I'll just abbreviate that, corresponding angles. And that's kind of the essence of these proofs. If you can work your way to find either alternate interiors that are congruent, consecutive interior that are supplementary, corresponding that are congruent like we did in this case, with parallel lines and a transversal, then you've got your proof.